Hello, in today's video we're going to be covering section 5.4 part 2, solving special systems of linear equations. Our EQ for the day is, can a system of linear equations have no solution or infinitely many solutions? What do these solutions mean? So I'd like for you to go ahead and do your best to recall part 1 of section 5.4 by pausing the video and practicing question 1 here on your own. To solve, I think everything's lined up nicely to use elimination, but you can use substitution if you would like, and we'll go ahead and avoid graphing just because that can be a little bit inaccurate. So to eliminate, I'm going to make my x's inverses, and to do that, I need to multiply my x term by a negative 2. Multiplying by negative 2x is then the opposite of positive 2x. So that's okay as long as I multiply everything by negative 2. So now that first equation is a negative 2x. Negative 2 times y is a negative 2y, and negative 2 times 3 is a negative 6. I can now add to eliminate. Negative 2x plus 2x is 0x, so 0x. 2y, take away 2y is a 0y, and that's equal to positive 2. So 0x's and 0y's is saying that 0 is equal to 2. Now this doesn't make any sense. We are looking for the value of either x or y that makes this statement true, but there's no variable even in that equation. There's nothing that could ever make that statement true because it is simply a false statement. There's no value that we can solve for a variable that could ever make this true, which means that there is no solution. There is no value for a variable that will ever make this true. Moving on to our new part of 5.4, we're going to talk about example 2. Still solving the system of linear equations, we can use either substitution or elimination. Here, since the y is only with a coefficient of 1, or there's no numbers shown here, I could go ahead and add 2x to both sides. But I prefer elimination when things are nicely lined up like this. And I see that it's pretty easy to multiply by a negative 2. To make this x term a positive 4, which would be the opposite of negative 4 in the equation below. So multiplying, I now have a positive 4x, which gives me the opposite of negative 4x, just like I wanted. I've got a negative 2y is equal to, and then a negative 6. So now I add 4x and negative 4x give me 0 x's, 2y and negative 2y give me 0 y's. And 6 take away 6 is 0. So what we're looking for is the value of the variable that makes this statement true. So 0 plus 0 is equal to 0, which means that 0 is equal to 0. So I want the value of the variable that makes this statement true. Well, this statement is true. We don't care what the value of either x or y is because this statement is true no matter what. There's no x or y in this statement to even worry about. Which means exactly the opposite of no solution. There is an infinite number of solutions. I'd like to go ahead and see what this looks like graphically. So go ahead and take a moment, pause the video, and practice graphing each of these two lines in the coordinate plane shown. My first equation, I'm going to go ahead and add the 2x to both sides to put it in y equals mx plus b form. So y is equal to positive 2x plus 3, which means that b is equal to 3 and m is equal to 2. So b is 3 and then m is 2, so up 1, right 1, up 1, right 1, up 2, right 1, excuse me. I could also go down to left 1. And my equation would look something like, my graph would look something like this. And then my second equation, I'll go ahead and add 4x to both sides. 2y is equal to 4x plus 6. And then I want to isolate y, so I have to divide everything by 2. So one thing that I would like to bring to your attention is that when we are solving a system of equations, we are looking for the point where they cross. So when I graph this line, I am looking for the point of intersection. So this one, I go up to a y-intercept of 3. Well, it looks like they cross there. But my slope is 2 or 2 over 1, so up 2, right 1. They have another point in common. Up 2, right 1. There's another point in common. Up 2, right 1, another point. Down 2, left 1, another point, and another point. Which means that when I go to sketch this line, it's actually exactly the same line that we had before. These are the exact same line, which means that they cross everywhere. So anything that's true for one equation is true for the other, meaning that there are infinitely many solutions. There's not just one place where they cross everywhere along their lines, and they go on forever upwards and downwards, so the answers or solutions are infinite. When there are infinitely many solutions, the two graphs coincide. This means that they are actually the same line. So whatever works for one equation also works for the other equation. Go ahead and take a moment and practice these two as well as the following two on your own. So pause the video and I will walk you through them shortly. For our first two, everything is set up nicely for elimination. So I will choose to eliminate my x's and multiply everything by a -2. That makes my x a positive 8y. So I've positive 8x, so 8x. -2 times -5 is positive 10y, and -2 times positive 4 is a -8. Then I add. 8's are opposites, so 0. Y's are opposites, so 0 is equal to 8 minus 8 is 0. So what I've got is 0 is equal to 0. No variables, but this is a true statement, which means I've got infinite solutions. Number 2, I will go ahead and I'll use elimination again. I'll multiply everything by a positive 2 this time. That turns my 2x into a 4x, my positive 3 becomes positive 6y, and my -4 becomes a -8. Then I add. -4 and positive 4x give me 0, -6 and positive 6 give me 0, -4 and -8 give me -12, so 0 is equal to -12. This is a false statement. There are no variables for me to solve for, which tells me that this is a false statement. So there is no solution. Just like the very first one we did in our notes today, that was the recap from part 1 of 5.4. If you haven't already paused to complete numbers 1 and 2 here, go ahead and do that now. This one I'd like to use substitution on because the y is already by itself. So I'll go ahead and solve by replacing my y in the first equation. So -3x plus 2 times y is equal to -15. For y, I'm going to put in a 5x minus 11, and then I solve. So -3x plus 2 times 5x is 10x. 2 times -11 is a -22 is equal to -15. When I add, I've got 7x minus 22 is equal to -15. Adding 22 to both sides, 7x is equal to 7, so x is equal to 1. So this system does have a solution. I know that x is 1, so I need to go back and find my y value. So I'll use that second equation just because it's the easiest one to solve for y in. I know that y is equal to 5x minus 11. If x is equal to 1, then y is going to equal 5 minus 11. So y is equal to -6, which means that my solution is the coordinate 1, -6. So my lines intersect at the point 1, -6. In number 2, I'll go ahead and go back to using elimination. I'll multiply everything by 2's. Multiplying by 2, I've got a negative 10x minus 4y is equal to negative 6. And then adding, my 10's are inverses, so 0x, plus my y's are inverses, 0y's, equals 12 minus 6 is 6. So 0 equals 6. There are no more variables, and this is a false statement, meaning that there is no solution. All right, that brings us to the end of our video today. Thanks so much for watching.